Okay, so now is our last topic. We have a lot of clues telling us that that bedroom variable is really something bad. Okay, so that somehow motivate us to ask, is there a way to really test whether one variable is really meaningful in explaining or predicting that dependent variable? Okay, so we want to somehow validate our regression model by testing the significance of each coefficient. So let me tell you what does that mean. Suppose we have two independent variables and we get this regression formula. Okay? Now we know both these two coefficients are just calculated based on the sample data. They are not really the true parameters that we want to know. Okay? Just like when we have population mean, we don't know it, so we use sample mean to do estimation. We have beta 1 and beta 2. They are parameters, but we don't know them. So we use sample data to estimate them. Okay? 2.8 and negative 15.8. These are just estimates. So if they are just sample data, even if they are not zero, we actually cannot be sure that beta 1 and beta 2 are not zero. Okay? So that means we somehow want to do a test about whether beta 1 is 0 or not, whether beta 2 is 0 or not, just like what we did for testing population mean or population proportion. We hope that we will have a strong enough evidence in our sample showing that we have we can make allowing us to believe that beta I is really not zero. Okay, we hope that our sample data can give us a clue about it. So I'm not going to tell you the details about how to do this, but the only thing that you need to do to understand it is to recall your t-test. Okay? We assume that the population mean is somewhere, and then we collect sample data. If the sample mean is so far from population mean, the assumed population mean, we're not going to believe that it's possible. Okay? The p-value is the probability for us to see such an extreme value. If p-value is very small, we don't believe that our hypothesis, our null hypothesis, is really true. So here is the same thing. We're going to assume that beta I is 0, is actually 0. Okay, we're going to assume that xi actually has no impact on y. And then we collect data. If our beta I is actually far from 0 in some sense, then we have strong evidence showing that beta I is not 0. Okay? What I mentioned about in some sense actually depends on, for example, something like sample variance or sample standard deviation. Okay? So that's why in the next page, when you see the outcome, you understand it. When we do the test, when we do the regression, our testing results are actually provided in those reports, like here. If you go back to check your R report, you see something like this. We will see that there is a column called the probability of greater than the average, absolute value of t. Okay, so what's that mean? This column is exactly your p-value. Okay, it's exactly your p-value. So you know that we are doing tests about whether beta 1 is 0, about whether beta 2 is 0. For beta 1, the p-value, okay, the p-values has been multiplied by 2. So we should compare them with alpha directly because this is a two-tailed test. This p-value should be compared with, for example, 5%. If that's the case, p-value is less than alpha. That means we can reject H0. At a 95% confidence level, we believe that beta 1 is really not zero. House size really has its impact on house price. Okay, now we are confident to say that 2.8 is not something by chance. Okay, 2.8 is really there. There is really a positive impact from size to price. But interestingly, for bedroom, you see the p-value is so large. Okay, so we cannot reject H0. There is no conclusion we can make about it. We have no evidence to say that bedroom really has an impact. So when we see this, when we see such a large p-value, it is again suggesting us to remove the variable bedroom from our regression model. This particular number is suggesting us that bedroom is useless in our model. In Excel, again, if we look at this report, we see these guys, not just coefficients, but also their p-values. Again, these p-values has been multiplied by 2, and you see these are exactly the numbers you read in the previous slides. Okay, so it's quite useful. It's quite useful. If we go back to our problem with only size as an indicator variable, okay, check this by yourself. We're going to see that its p-value will become less than 1%. So we will be quite confident that it really has its impact. It really has its impact. Okay, now it's time to summarize what we have up to now. We know what's a regression model. We basically know that it's trying to identify how independent variables affect dependent variables. For a linear regression model, we adapt the least square approximation for estimating the coefficients. So you know, you don't really need to do the calculation by yourself, but you know the concept. What we are trying to do is to find a straight line or a plane or whatever, a linear function, so that the sum of square root is sum of square error is minimized. The overall quality is described by R square and adjusted R square. Adjusted R square is used for comparing multiple models. But if you are talking about for what percentage of that dependent variable can be explained by those independent variables, then it's R square. We can also test the significance of each independent variable. Even if they have a positive or negative coefficient in the regression model we have, that may simply be some error from the sampling, right? So we need to test whether that coefficient is really not zero, and those p-values is going to give us an answer. In the lecture on Monday, I will give you more examples, more discussions, and then in the next lecture, we need to talk about something more. For example, about when we have multiple independent variables, what are some guidelines to select independent variables? We will also see some examples that, based on old current independent variables, we need to create new independent variables. That's going to greatly enhance the quality of our regression model. And finally, we will talk, if we have time, we will probably talk about some more about how to validate the model, if we have time. Anyway, I'll stop here. Thank you.